start the recording. All right, cool. All right. There's still a few more people coming in, so I'm gonna actually see. All right. All right, so we're gonna review rock paper scissors first, real quick. Rock paper scissors first, real quick. So if you remember, because it'll help us with the tic-tac-toe. So remember, in programs, and especially if you want to program like a game or something, you need three parts: the input, operation, and the output. For rock paper scissors, the inputs you'll need are the number of rounds and each person's own individual choice and whatever they want to choose for their rock, paper, scissors, such as rock, paper, scissors. So that's the inputs you'll need. And then for operations, you'll simply have to do the if statement combinations like that, where you have to use a bunch of repeating if statements in order to figure out exactly who picked what, and to tell who wins. You'll have to be pretty specific with your if statements, essentially saying if person A chose one thing and then person B chose the other, then this exact thing will happen. This is kind of unique to rock, paper, scissors, where your if statement will have to be super specific, where if you don't, where essentially our if statement is going to be exactly if it equals A, and if person A picked one and person B picked one, then output tie. For lots of other programs, usually there'll be like a range of inputs, where as long as within that range, you can then output like the answer or whatever whatever you want to output. Rock, paper, scissors is special because it has like very clearly defined rules, and there's no real way to like kind of like easily there's no way to like operate through those rules without just memorization. There's no like, you can't make like a mathematical formula thing. Whereas in like a card game, for example, you might be able to have your program simply just add up together numbers in order to figure out the output. But in rock, paper, scissors, you have to manually write out each output, which is kind of one of the things that makes it different from many other things. So yeah, let's move on to the main topic of today's session, which is finishing tic-tac-toe. So let me just move this over real quick. But last in class, we talked about the first bits of tic-tac-toe. Specifically, we talked about inputs, where first of all, we get the number of rounds we want to play tic-tac-toe. And then we can use a for loop. Remember, for loops are repetition. So when we get the number of rounds, we can then use this number and tell the program we want to repeat the same thing this many times. Since each tic-tac-toe game will be using the exact same program, the only difference will be in user input, which will be counted for here. But since the actual game itself is the same, it doesn't depend on the previous games. We can use a for loop, which will simply repeat the specific game process over and over again. So we can use a for loop for the number of rounds. And each time we have to reinitialize, we have to remake the board. Remember, here we recreate a new board, a new 2D array called board, or a new double array called board. And it has 3 columns and 3 rows, which is exactly what a tic-tac-toe board looks like. Because we put an equal sign here, set one to a new int, that means every time this for loop finishes, when it goes to the end and has to repeat, it will recreate an empty board because it's creating a new double integer array, as you can see here. So this will automatically reset the board for us. You could also, one thing you could also try is move it outside, which would no longer reset the board. You would have to instead rewrite it manually, such as here, you would have to write the name of it, which would be board is equal to new int. You could also put this outside and simply reset it in the for loop like that as well. But that's not really, but since this is in tic-tac-toe, you don't really have to do that. You can simply put it here and it's a lot less of a hassle, but you can put it outside. Also, one thing to note, however, is if you do put it inside, you can't access it outside the for loop because this will only exist inside of the closest bracket. If you put it outside, you could access the final board after each of the for loops has gone through. So if you wanted to do something that you could, but again, tic-tac-toe doesn't really need it to do anything with that. Yeah. Also, one extra important information is I've been calling these double arrays, but the more proper name for it is 2D array, because because you can remember, you can think of these arrays as a sort of row by column board. So a 2D array is two-dimensional. It has a height and it has a width specifically. A one-dimensional array would simply be, you just get rid of the extra bracket, and that'll be a one-dimensional array because again, it's one-dimensional. This list would just be a line. But with the extra bracket, it makes rows and columns because each list contains a list. Or in other words, each row would contain a column. And so that would make a 2D array. And again, obviously, if you extended it, you would create a 3D or 4D array and so on and so forth. Yeah. And then next, we also talked about how to do player inputs, where in this case, this gives us where player one wants to put their thing. So it gives the player one has to type in a row, type in a column. And remember, the way basically all programming languages handle list positions is it starts from 0 and then goes to the end of the list size -1. So if you wanted to put something in the very bottom right corner, you wouldn't say row 3, column 3, you would say the row 2, column 2, because it goes from 0, 1, 2, not 1, 2, 3. You could, if you want to, what you could do is make it so the player can type 1, 2, 3. You would simply have to adjust for it whenever you actually check the actual rows and calls. So for example, you would have to write a bunch of -1s here because again, lists and arrays in basically every programming language start from 0 and move on. So if you had a list that's the size of a 3, it would only go up to 0, 1, 2, not 0, 1, 2, 3, because then that would be 4 elements. So you have to make sure to account for that when you're either doing inputs or whenever you're doing inputs or whenever you're doing calculations. So yeah, and then finally we talked about operations. The main operation in tic-tac-toe is checking if a spot is filled, which is exactly what this does. If the board, our tic-tac-toe board, at the position at this row and this column is equal to 0, or in other words, if it's empty, because it has a value of 0, so there's nothing in it, then we can set it to 1. If it's not empty, then we can't set it to anything because it's already filled. However, you might notice something. If we implement it exactly like this, then if the player inputs an incorrect row and column, it would straight up skip their turn because otherwise the player wouldn't place anything and it would move straight on to player 2. So then how can we make it so the player is guaranteed to input something? You would have to repeat this process until the player inputs the correct row and column, right? However, because this repetition can take a potentially infinite number of times if the player is being, if the player is just not doing it correctly, or because they're reading the board incorrectly, a for loop doesn't really work here. Because remember, a for loop does repeat something a specific number of times, not a random number of times. So this means we have to use the other repetition function, which is called while. A while loop is very similar to a for loop in which it will repeat the process inside of the brackets until some conditions fulfilled. Essentially, a while loop is a combination of a for loop and an if loop. It takes the for loop repetition, but uses an if function to decide when this for loop should end. So essentially, this piece of code writes while the board at the position row column does not equal 0, do something. So in this case, we have to do this. We could then copy this back in, right, like this. We would also remember you can't, and here we have to get rid of this in part because we're not defining a new bucket. This row and column already exists outside. So we simply have to just call a name. We don't make it a new bucket because it already knows the type bucket it is. So we're keeping it. So in other words, you're just reusing the bucket here. So while the board at row column is not equal to 0, we ask player to choose a new row and column. And then we update it here. And then outside, we can then update the board at this row and column to be right, to be 1. So to go real quick, first, what we do at the beginning of each game, first what we do at the beginning of each game is we tell a player to choose a row and column. Then they type in 2 numbers, which is the row and column. And then we check it. If the place they chose is invalid or the place they chose does not equal 0, we tell them to choose again. And this because the while loop will run and if they choose an invalid position again, it will check this if function again. And if it's true again, then we'll rerun it. So in other words, every time the player chooses a position that is not empty or does not equal 0, then it'll keep running it over and over again until they finally choose one that does equal 0. Then this will be false and the computer will know to stop running this while loop. And then it will move on to the next line of code, which assigns this value to 1. Then after that, we'll have to check whether or not they win. Here you can see, and here this is a little bit of extra information, but this is called a comment. In Java, the comments are written with these 2 backslashes, and basically this means you can write whatever you want here, and it won't affect the program. It's essentially a comment. So this is how you can make little notes in your code for things you might want to do later or whatever. That way you don't have to type in actual words. This way you can type it in and the program will self-function. So this is how you essentially make comments. Yeah, so then after that, we have to check if they win. And then we can move on to player 2. Then we can simply copy over what we did for player 1 here. And then we will then have to check if player 2 wins. Okay, now one more thing we will have to add is this has to keep going until someone wins, right? If someone doesn't win, then the game will keep going until it's a tie or someone wins. So that means we have to, again, add another repetition. Or instead of repeating rounds this time, we're simply repeating turns until someone wins. In this case, we'll have to use another while loop that contains this entire section of code. And this while loop essentially is going to say, while the game is not finished, keep repeating these turns until someone wins. Then when someone wins or ties, this while loop will finish, it'll move to the end. And since the end is in the end of the for loop, it'll go back to the for function and then repeat this while loop again until the number of rounds has been satisfied. So here we'll need to put in another if function that tells us if the game has been won. In this case, what we can do is we can simply, remember, an if function doesn't actually need a question. It simply needs something that can be output to one of 2 things, true or false. It needs to have, it doesn't actually need a question. It just needs an object with 2 values, true or false. Normally we use a question because this question, which is going to be yes or no question, can output a true false value. For example, in this while loop, as you can see, this while loop takes in what is essentially a question. And then this question will return, it will output a true or false. Or you could simply write the word true, or you can simply put in a value that is already true or false. While you could just write the word true or false in there, we need to have some way to tell the program to change it to false. The way we can do that is with another bucket. Someone asked me a question. So I can't really paste the code in chat because the chat window is kind of small and this is kind of a lot, but I will put the code on the classroom after this class. If you really want me to put in the code chat, I can do that if you want, but otherwise, I think it'd be much better if I leave on the website since the screen is bigger and the text is easy to see there. And I will put the video as soon as possible onto the YouTube anyway, so if you need to watch it, that's also good. All right. Anyway, as I was saying, the while function doesn't technically need a it doesn't need a question. It needs a true or false value, and the most common way of doing that is simply to ask the program a question, and the program will automatically run through it and give a true or false value. But another way we can give it a true or false value that can change. Because remember, if the while loop, if the true false value in the while loop doesn't change, it will either run forever or it will never run. Because the while loop runs as long as the question, as long as this value is true. But one way we can give it a true false value that can still change is by making another bucket, another variable. In this case, we can simply make a Boolean variable. We can call it game state. We'll set it to true. Then we can simply put game state here. So in this case, to a quick review, Boolean simply just means this bucket, this variable can contain one of two things. It can contain a true value, a 1, or it can contain a false, a 0. In this case, we're going to leave it as true. And so this while function essentially says while true. Of course, this is enough. We have to make some way inside the while function to turn game state false, because otherwise this will run forever. The while loop will only stop once the condition inside is false, similar to how a for statement will run forever until that statement is false. Specifically, the way we'll do it is simply after the check function, after the check win, we'll simply, if check win is true, we'll set game state to whatever the check function outputs. So let's start on that then. All right, again, I'm going to scroll through this real quick. So if you want, you can type it down. Also, if I'm going a bit fast, you can also tell me. All right, so now we have to actually figure out how to check player wins. This one is going to require a sort of similar method to the if function that we did for rock, paper, scissors, in which it's going to take a lot of checking functions, especially since the tic-tac board is both bigger and there's a lot more values that you have to search for. However, because we're looking for patterns, we don't have to check every individual solution. In rock, paper, scissors, we had to include a function for every single possible occurrence, because rock, paper, scissors, the rules are purely a matter of memorization. You can't simply just think of it on fly. But tic-tac-toe, the only rule is 3 in a row. So you don't actually have to remember every single 3 in a row. You can simply just check for 3 in a row and apply it to each position. So in other words, we can use a for loop to simply check for 3 nodes in the board. So we can, and because we're going to be repeating this function, and the only thing we're really going to be changing is the player we're checking for, we can make it a method, which again is a mini program that takes in inputs. In this case, one bucket that contains a number, an int player, one 2D array or the board, and it will have, and the operations will go inside here, and they will return a true or false value. So let's go check horizontal wins first and see if we can do that. For horizontal wins, what we'll want to do is we're going to first move it back to I first, and then J here. So if we want to check for horizontal wins, we'll have to go through each row and check each individual element in that row. So we have to check through each row. So this will help us check each row. This for function will go from 0 to 1 to 2, and then because the 3 will stop because 3 is no longer less than 3. So I'll stop there. Oh. So this will again check the row 0, the row 1, and then the row 2. Then for each row, we'll want to check each individual element in that row. We have to check every part of that row. So this next for loop, int j, will then help us check each element. I'll check the first element of that row, the second, and then the third, and then it'll stop there because then we'll know, because then it will have to break there. So the actual value will be equal to board ij. So this value, remember, so the way 2D arrays works is the first number can be seen as the row, and the second number can be seen as the column. So in this case, this will be, so if I draw a picture out, right? So I'll look at the first row, the row 0, and I'll look at the column 0 right here. And then as j increases, it'll look through each individual element in that row. And then once it goes through each one, it'll move on to the next row and then the next. So the first value in each row, well, then each value from this board can be stored into a bucket called value. And this value will keep changing as we check the next element. So then we simply have to check whether or not this value does not equal player. Because we know as soon as it does not equal the player, there cannot possibly be a 3 in a row. Because a 3 in row in a tic-tac-toe board takes every single space in a row or column. So if at least one value does not equal player, we immediately know that it cannot possibly be a 3 in a row there. So we can immediately skip or break this for function and immediately get out of this row and move on to the next one. Remember, a break function right here, this break statement, what it does is as soon as the program reaches it, it'll check. If it's in a loop, it will immediately break out of the loop. In this case, this will prevent the program from checking extra spaces because we don't need to check those spaces anymore because we already know there's not 3 in a row there. So the break will immediately break out of this repetition loop. It only breaks out of the first loop it encounters, not every loop. So only break out of this loop, which is good because then it will automatically finish this loop and it'll move on to the next row because this loop has not been broken. So this will essentially tell the program to skip to next row. And then we need to have, so now we figure out how to check if it's not a 3 in a row. Now we need somebody to check if it is a 3 in a row. Now, if it is a 3 in a row, that means every time it's gone through this function, it's never ever broken. So that means what we can do is we can put another Boolean, another true or false bucket here. Right? And we're going to set to true. So as soon as the player does not equal value, what we can do is we can set this bucket, this storage space to false. Because again, as soon as it reaches this inside statement, this means this if function has to pass a true value. And it only does that if the player number does not equal the value inside the board. And if that happens, it's impossible for the 3 in a row. So the win at this row cannot be true. Then outside of this for loop, we can write if win is true, return true. Or since win is already a value true, we can simply simplify to just win. So essentially, remember, win is only true if it goes through each value and the player is always equal to value. If the player is always equal to value, then win is never set to a false value. So it's always true. So that means that there is a 3 in a row in this position. And then if there isn't, it will move on to the next row, reset win to true, check through each element in the row again. And if this ever happens, it'll set it to false. And then once this for loop finishes, either because it went to the end or because it got broken out of, it will check the bucket, it will check the storage value, the variable win. And if it's true, it'll return true. This will allow us to check every single horizontal position. Now, how do you think we're going to check the vertical positions then? Instead of each element in a row, we're going to check each element in a column. How do you think we're going to do that? I'll give you a hint. It's very similar to checking rows. Really, you only have to switch over a couple numbers. Yes. So you simply have to switch I and j around. So we're going to copy this over because you can think of checking vertical rows as basically the same thing as checking horizontal. You simply have to flip the board around. So here we can simply swap this around, and we'll have to swap these two around. Or so you can swap it like that, or you can swap it like this. Both which is similar. Essentially what this means is the value we're checking is no longer each subsequent element in a row. Because as you can see here, the value that's changing the most often is no longer in the second position. In this loop, the value j changed value a total of 9 times. It would change 3 times each loop. And since this loop repeats 3 times, 3 times 3 is 9. So value j repeats 9 times. And I'll check each element in a row like that. However, here, j, which is still changing 9 times, since it's for loop outside hasn't changed, is now in the first position. In other words, this time the number that's changing most often is no longer the column, but the row. Here we move from column 1 to column 2 to column 3 along a single row. So we check this first column and then the second column and this third column, and then we check with the specific, but the row number changed only 3 times going down. But since here, the one that's changing least often is in the column position. Now the column position will stay the same. So if we're checking column 0, it will stay in column 0 until we check each row. So in other words, essentially here, I and j, when I and j are both 0, it will check 1. But j increases to 1, so we'll check the second row or row 1 in terms of how the array stores it. But we're still checking the 0th element. So we'll go down 1 row, but check the 0th element in that position. And then j will increase again to 2. And then I will still be at 0. So when we look at the board, the program go, okay, board at position 2. So it's going to look for the second list or the second row. So row 0, row 1, row 2. And then we'll check position I, which is 0. So this right here is 0. If I is 2 and board is 1, if I is 2 and j is 1, I go to the first row, the row 1, and I'll go to the second position, 0, 1, 2. And we can do the exact same thing. It will check each value in that column. And if it's ever in an incorrect value, we know there can't be a 3 in a row there. So the win bucket, the win variable is set to false and we break. And if it's ever true, we return true. So that's how we can do the vertical wins. However, there's still one subset of wins that we do need to check. And that is diagonal wins. Now, diagonal wins are a lot harder to check with this method because first of all, there's only 2 of them. Whereas with horizontal vertical wins, there are 3 of them and they're in this constant pattern. Diagonal wins they don't really have a pattern to them. They're straight opposites of each other. So you could try to use a for loop again, but this time it'll only be a single for loop. The reason is both I and j change at the same time if you're trying to check a diagonal. For example, if you're trying to check a top left to bottom right diagonal, then we'll start from position 0, 0, and then we'll increase the row by 1 and the column by 1. And then we'll increase the row by 1 and the column by 1 again. Since they're both changing at the same time, we can use one for loop to change both of these values. And the same thing happens when you go the other direction as well. So for the top left to bottom right diagonal, we can sort of copy it, but we'll have to get rid of this one. Okay. All right, so I'll have to move this. All right. And then we'll move this here. All right, so here what we essentially did is we expanded the previous for loop by removing the outside for loop. So here we set the win true outside as the first thing we do. Then we do for the for loop, we repeat for each value, the 3 values in the 3 in a row. So this 3 in a row contains the value at 0, 0, 1, 1, 2, 2, 0, and so I will go from 0, 0 to 1, 1 to 2, 2. Since we use I twice, this means that the value of both of these will be exactly the same. So it'll be board at 0, 0, board at 1, 1, board at 2, 2. This is the for loop. If this is ever false, we break out of the loop because there's not possible for a 3 in a row there. And then if win is still true after all the 3 of those loops, we return a true. For the other way around, we can simply do the same, or just have to reverse it. In this case, what we did is we're essentially going backwards. So when I is 0, we're checking row 0, column 2, because we're going from 2 minus 0. So we are at column 2. Then when I is 1, we'll check at 1 and 2 minus 1, we're 1. So we'll check the middle again. And then when I is 2, we'll check at position 2 and position 2 minus 2, which is 0. So check this position here. This is essentially a little piece of handy math right here. So if you want to go backwards in a for loop and still check if you want to check the forward values and the backward values, you can use one for loop and check the backward values by simply writing the maximum In this case, the maximum is 2 because again, lists in programming languages start from 0 and go up to the maximum size -1. So since we have 3 rows, it starts from 0 to 1 to 2, which is 3 rows. So we have to start from 2. If we start from 3, then when I is equal to 0, it'll be 3 minus 0, and it'll be 3, but there is no row 3. There's only row 2, 1, and 0. So you have to start from 2 minus 1. Then, so 2 minus I. So every time this for loop repeats, we'll have 2 minus 0, 2 minus 1, and 2 minus 2. Or in other words, it'll give us the values 2, 1, 0 instead of 0, 1, 2. So this allows us to go backwards in a for loop. If you wanted to, you could also have the for loop go backwards instead like this. Remember, if you do it like this, this has to be greater than or equal to 0, not greater than 0, because we still want 0. And this will have to be minus minus. And then here you would simply have, and you would have to reverse it like that. Both these methods works, it's as long as you know how to check the diagonals, and that's fine. In order to check the diagonals, you can still do the repeating process from earlier, but you'll have to adjust for the fact that the diagonals are kind of unique, and the fact that one of the diagonals has reversed values. Specifically, the top left, the top right to bottom left diagonal will, as you just saw, the row and column values are one increases, the other decreases at a constant rate. So here, this will allow us to check all the diagonals. Now we've checked all the horizontals, all the verticals, and all the diagonals. So that means that the only possibility left, right, is that the person did not win. And we'd be kind of right, but there is one value that we haven't accounted for here, and that is a tie. A tie in tic-tac-toe would be if you went through the check win and no one won, but every space on the board is still filled. So you could put the check for tie in this function, in this method, and you could do that. However, you would have to change it from returning a Boolean value to a number value. Because remember, a Boolean, a true false value, can only hold 2 values, true or false. But since we have a win value, a lose value, and a tie value, that's 3 values, which can't be represented with a Boolean. So you have to change to an int and output, like say 0, 1, and 2, where 0 is win, 1 is lose, and like 2 is tie. Something like that. But what we can do instead is make a second method that checks ties. And we can do that by borrowing the check win method. So what we can do here . So in order to check a tie, what we can do is we can first call check win. Check win, as we said, already checks all the possible wins. So if a player will win, it will output true. And if all of these 4 functions, every single one of them never outputs a true value, that means this person must not have won yet. So it will return a false value at the very end. So what we can do is do if check win, and we give it the necessary input, which is an int value for player and board. So if this gives us a false value, in other words, no, because if it gives us a true value, that means there can't possibly be a tie because someone won. So if this gives us a true value, I'm sorry, a false value, and you can simplify this to simply exclamation mark, which in programming simply means the other value. For Booleans, the other value is simply the value that it's not. So essentially, if it reverses it, true becomes false, and false becomes true. So essentially, the exclamation mark just reverses the Boolean value to its opposite value. So here we're saying if the value returned by check win is false. The reason this works, remember, the if function only runs if the inside returns a true value. However, if check win returns a true value, it becomes reversed by the exclamation mark and become a false. But if check win outputs a false because no one is winning, then the false will get reversed and turn into a true. And because it's now a true value, the if function will then run. So if check win is false, no one has won yet, we then can check each value on the board. If we want to check each value, we'll need 2 for loops again, one to go through each row and one to go to each column. Okay, and then after that, we have to get each value in the board So, and then in this case, we want to make sure that the board is not empty. We already know no one's winning, so all I have to do is make sure there's not an empty space. So we can simply do if value does not equal 0. Essentially, we want to check to make sure that each value does not equal 0. So we can do it the way we did above, where instead we check if it is 0. And if it is 0, we return false. Essentially, if as long as one of the values is not 0, if at least one of the values is 0, if any value inside this board is 0, then this will immediately return a false because it's still an empty space, and thus the game can still be played. While the game might be guaranteed to become a tie, you still have to play the game to the end. So in this case, it will always return a false. It will always return not a tie if at least one value is still empty. However, if it goes through this entire loop, remember this loop checks every value on the board. So if it goes through every value and not a single one is 0, we know every single value must be filled, which means that there must be a win condition. So, that means the entire bill is filled. And because we know no one has won, it must be a tie. So we simply return true. And finally, we have to figure out what happens if this if function is false. If this if function is false, that means there's a win, which means there is not a tie. So it will also return false. Now that we have a function that checks ties and wins, we can then actually implement it here. If Right. I forgot. Also, for these functions, you need to add the word static to it. Static is a keyword that we'll get into later, but for now, all you basically need to know is that static essentially means that this program is allowed to use this method. We'll go into it a bit more in detail, probably in the next class where we'll talk about classes. But yeah, for right now, you just need to know that it makes the methods work. Similar to how there's a static up here as well. Yeah, so here we have to check if there's a win. If they place down this value, if they place down a number, an X, and if that X wins the game, or if they win anywhere really, then this will output, then we can simply tell the program to say, player 1 wins. We can then set this game state to false, because now we have to stop the game from playing because it's over and we can move on to the next round. And because we don't want to go on to the second player, we'll have to also put a break here to immediately get out of this. We have to immediately get out of the loop. And that does actually mean we don't need a game state because it'll automatically break out of the while loop. But it's still a good idea to leave it in here so that way you can clearly see what's happening here. This is kind of a good marker for it. And finally, after you do that, we also have to check tie. And if tie returns a true, we output tie. We have to set game state to the false value. Now we have to break out of this game. And then we do the same thing for player 2. Except we change it to the 2 value. So let's go through it again. So it will take in a number from the user, which is a number of rounds of tic-tac-toe. Then it will repeat tic-tac-toe that number of times. I'll create a new board every time as the first thing it does. I'll create a Boolean container called game state and set it to true. And while this game state is true, it will constantly repeat the turns. Each turn consists of a player 1 turn where they choose a row and column. They will then, and then this while function will make sure that the row and column is guaranteed to be on an empty space because it will check the space. And if it's not empty, if it does not equal 0, it will then tell them, it will force them to choose a new number and repeat this until they give an acceptable number. We'll then set that area to 1. Then we check if the player wins. We check if the player ties. If both of these are false, that means the game must still be going on. So then we check player 2. And for player 2, do the same thing. We get the input. We make sure the input is correct. We have to make sure that the input is correct. Then we change the board. We do our operations, which checks whether or not we should output something. And if we should output something, we output it. And finally, once all this is over, we finish the round, which we can mark with, say, a print statement saying next round, for example. And then we'll go back to the beginning of this for loop and constantly repeat it again until we get it, until all the rounds are over. If you want to, you could store the number of wins by creating an int container, like say P1 wins is equal to 0, P2 wins is equal to 0. And then every time one of them wins, you could add a win. You could add a win to that bucket. And you could also create a bucket for ties as well and add it to here as well. So yeah. And you could also do the same thing for player 2. Now, one thing you might notice is that the player 1 turn and the player 2 turn are very similar. In fact, they're actually exactly the same. The code we use here is exactly the same. The only thing that changes is this number. It goes from 1 to 2 and then 2 to 1. So one way we could shorten this code drastically is, first of all, we could create a method, right? And this method simply takes in a player value, 1 or 2, and then it will simply run through this exact code, except whenever it uses number, it will then replace it with the gathered input. Or you could have a Boolean value that alternates between true or false. And if it's true, it's player 1. If it's false, it's player 2. So let's try to implement that. It's always a good idea to not have repeating code sections like this here, because it just makes code confusing, long, and really hard to read. If you can condense it, that's always preferred. So let's try to condense it a bit. In this case, what we can do here, so what we can do here is, instead of using 1, we can simply have an int value called int current turn. And this value will simply store the current turn. So it always starts at 1 because it always starts with player 1. So first off, if you want to condense it, we have to adjust every single part where it uses a 1 or 2, wherever it uses a player number. So here we'll have to split this into 2 strings instead. So this says essentially the exact same things before. Player 1, choose your own column. But by adding a bucket whose variable, whose number we can change, we can then cause this string, this word, to change, to output something slightly different every time we run it. So after this is over, we can then set current turn to 2, and when we run it again, instead print out player 2 instead of player 1. So we can then move this side here as well. And here. That's not really what I meant to do. Okay, cool. And then instead of writing 1 here, we can write current turn, and current turn. And in order to adjust wins, we'd have to do an if statement that checks the turn. So if current turn equals 1, then P1 wins, we add 1 to that value. And if that's not per 1, we don't have to, and then for the next one, we don't actually have to check it. Remember, an else function, an if else, if the if is ever false, then the else function will automatically run, but it will only run if this if function false. It's essentially saying, if this is true, run what's in here, else or otherwise what's in here. And since there's only one other possibility, you can simply write P2 wins possible. You don't actually have to check it here because again, there's only one other possibility. So let's get rid of this. Now we have this. However, as you can see here, it says here that current turn is always true because we have not updated the current turn. how will we update current terms that alternates between 1 and 2? How do you think we would do that for every term? We need some way to change current term from 1 to 2. There are two methods of doing this. One is you can leave it as a number, and others by changing it to a different container. How would you guys think you might approach this question? Yeah, so first of all, we can simply use an if function and say this: if current term is equal to 1, simply set current term to 2. And else, the only other possible value for current term right now is 2. In other words, if current term is equal to 2, we set current term to 1. And this will cause current term to constantly alternate between 1 and 2. After it finishes one term, we move on to here, and if it's equal to 1, it'll set to 2. And if it's not equal to 1, or in other words, it's equal to 2, since it's the only other possible value right now, it'll set it equal to 1. And then this will allow it to constantly alternate between terms, because as you can see here, it will change between 1 and 2. So it will always adjust the current player's turn, and we don't have to have that giant piece of repetitive code. Another way you could do it is by simply changing current term to a Boolean value instead. But that would then mess with this area here, and you would have to adjust for that as well. So I prefer leaving it in the int value here. So yeah. So that's tic-tac-toe. Now, the game itself is finished, but half of the game is actually seeing it. And right now, you can't actually see the board. You simply have to kind of just memorize the board and play that way. So now we need to make it so that the players can actually see the board and view it. And like whenever they type in something, whenever type in a wrong column they choose, it has to actually change. Now, this is a bit, this is definitely a bit new. We haven't actually done stuff like that before yet. So, but remember, if you want to show the board, there's really only one way to do that, and it's by outputting something. In this case, we can simply use system.out.print lines in order to print out a picture of the board. So one example, for example, we could go through each value using a double for loop again and print out each successive value. For example, like I'm going to just steal this. So after every term, right here, actually, we probably want to do it at the beginning of the term. So right here, obviously, we're going to have to use a double for loop in some way. We'll have to change to something else because we've already used the letter I. Okay, so obviously we need to use double for loop because if we want to print out the board, we need to know the value of every single point on the board, right? So we have to use a double for loop in order to get every value. There are other ways, but this is the most descriptive. So this way, this will allow us to access every single value on the board. Now that we have each value, we needed some way to print them out, and we can simply do that with the system.out, right? We print out each value. Now, we wanted to not just print out the values, we want to make it look like the board as much as possible. And tic-tac-toe board consists of 3 rows and 3 columns. Firstly, we have to get rid of this print line. The reason is it will automatically move to the next line, which is bad. We don't want it to move on to the next line until after we reach the end of the current line. We want to print out the 3 values in the first row and then move on to the next line. If we did a print line here, it will print each value on this new line. And instead of a 3x3 board, we would have a 9x1. And that is definitely not, actually, no, it'd be a 1x9, I believe, actually. Yeah, we definitely don't want that. So, but remember, if you get rid of the print line, it can print, it will keep the cursor at the same line. So when you print out a new value, it'll start from the same line rather than the same one. So now that we do it this way, instead of printing out each value on a new line, I'll print out each value on the same line. That's also not good. It's the same thing, but now it's just flipped. So how would we make it so that every 3 values, it would move on to the next line? How would you think we would do that inside this double for loop? So one way you could do it is by an if function. You could create a int value, let's set it to 0, and when it equals to 3, and you keep adding it to it, and once it equals 3, you could then tell the program to output a new line, to press enter. But we already have an int value that goes from 0 to 3. It's right here in this for loop. As soon as this for loop is over, remember, this means the entire row has finished. It has looked at every value in the row and it's about to move on to the next row. Right here in the between, right between it's about to move on to the next row is where we can add a print line and it will move on. So here, not only will the program look at the next row in the board, but the actual output will also move on to the next line. We want to leave it empty because we don't really need to add anything after that. And if we don't want to add another empty line here, because otherwise it would have 2 empty lines between each one. So now we've actually been at the board. Of course, if you want, you can also make it look a bit pretty by adding, like, say, lines between each value, and you can add like extra line here. And this little bit is not just to make it pretty to separate each value with a little line. And technically you don't need it, but it definitely makes it look a lot neater. Then it definitely makes it a lot neater, and you definitely want to, when you show the board to the player, you definitely want it to look pretty. So let's run the program and see how it goes. Oh wait, heck, I need it. So yeah, so one thing about IntelliJ is that when you run a program, it checks all the programs in your project, and if one of them isn't working, it will up an error. So if you do want to run something, you have to make sure everything is either working or it's all commented out and thus doesn't matter. So you can see here how many rounds. So again, the first bit of program is working fine. It's created a scanner object. So this allows us to get input, allows us to get the actual user stuff we need. And that's asking us how many rounds. And now the program is stopped because it needs to wait for user input. Using a scanner and putting an SE is one way you could, for example, like allow to delay the program, because program will not move on until after this line is finished, and it's not finished because there is no input yet. But now, let's say I type in, say, 3. Now that I've typed something, this line is now finished because this function can now actually do something. I typed in 3, this function is not able to return a 3. 3 is stored into the bucket, the variable rounds. So now rounds is equal to 3. It creates 2 new buckets, P1 wins, P2 wins, sets them to 0. And then finally, it moves on to starting the rounds. It creates an empty board, creates a bucket that holds a true false value that tells us when to end the game and the current turn. It will then go through and print the board at the beginning of each turn. And you can see it here. It will go through each value in a single row first, print it out along with a little line to separate it, and they'll print out a line here. So as you can see here, it works it seems to work fine. It seems to work fine. It's printed out an empty board, which is to be expected since the game just started, and each value is filled with a 0, or in this case, an empty space. Now it's asking us to choose a row and column. So let's go into the middle. Now the middle is changed to 1. Because remember, we put in a row and column, it takes that and it checks here, and since every single value is empty, it's fine. It will then set that value to the current turn. It will check wins, check ties, and then switch to now player 2. We can now choose a value, let's say 1, 1. but that doesn't work because it's already been filled. So let's say 1, 0, choose it, ta-da. And finally, let's check our win condition. And now we won because we typed 2, and that puts it here. However, you might notice that it immediately skips to the next round, doesn't show us the actual board. So this is an important step of programming. You can't just finish writing the program. You want to test the program, often by running the program, putting in test inputs and seeing if all the test inputs work as correctly. Here, we can see one thing that we probably want to add is that when they win, you still want to see the winning board. Otherwise, it's going to go from this to this. And now anyone who's looking at just the board can't really tell, what went on between here and there because no one has won yet. So how would we make it so that the program will output the current board whenever someone wins? How do you think we would do that? Yes, all we have to do is simply tell the program that this piece of code right here, the one that outputs our board, just repeat it whenever someone wins. Or ties. Of course, again, like I said, you really don't want to have repeating code because it makes it messy. So what we could do is condense it into a function. This function takes in a single board as its input. And it simply does this. This function does not have a value output. Its only output will simply be the system out.println line. It doesn't need to return any actual true or false values or anything. So now instead of having to write this lengthy piece of code over and over again, we simply write the word. That makes it much, much prettier. Yeah, you really want to condense your code as much as possible. You really don't want repeats because that makes it way harder to understand what you're writing. It's sort of like how in normal writing, you don't want to repeat things. And if you do have to repeat things, you usually don't want to reuse the exact same words. But yeah, so as you can see here, now we created a fully working tic-tac-toe game. So for next week, it's not next week, sorry, for the next class, what I guys can do is I want you guys to make sure you really understand everything here, because this is a really big thing to go through. And next time, what we're going to do is we're going to try coding some other basic games, but this time, I want you guys to try coding it like more of yourselves, sort of like it's going to be like a project almost, and you'll code it, and then I'll kind of like help you guys along the way. You can kind of choose your own game if you want, but try to keep it something simple like tic-tac-toe, rock, paper, scissors. Sorry. No, actually, no. We're going to code Connect 4 next time, right? And so Connect 4, as you might remember, it's Connect 4's board is pretty similar. It's a bit bigger, and instead of getting 3 rows, you have to get 4 rows. However, the big difference between Connect 4 and tic-tac-toe is that Connect 4, you don't choose your own column. You choose a column, and the piece has to automatically drop down to the bottom or as close to the bottom as possible if there's another piece filling it in. But it is going to borrow a lot of elements from tic-tac-toe. So for today's homework is essentially go through this program. I'm going to put it on the Google Classroom and make sure you understand it, and then try to prepare a little bit for Connect 4. You can try to work it through yourself by yourself, and then on Wednesday we'll come together and discuss it together. All right. All right. If you have any questions, you can stay after class. Otherwise, that's the end for today. Thank you guys for coming.
I have a question.
No problem. What is it?
Can I wrote a program, but it kind of is broken. Can I ask you to check if something's wrong?
You can share your screen and then I can take a look at it. Or if you want.
Could you like not share? Could you like unshare your screen? I can't share.
Yeah. I was about to do that.
Okay,
yeah, go ahead, share it, and then let me take a look at it.
Because, well, actually, I have 2 things. So here,
I can't see your screen. Are you sure you shared it?
Yeah.